Hello, boys and girls. Welcome to Patterns of Multiplying and Dividing by 10, 100, and 1000. In this lesson, we will discuss the meaning of the term pattern, identify patterns in multiplying and dividing by 10, 100, and 1000, compare the similarities and differences between the patterns of multiplying and dividing by 10, 100, and 1000. And we will multiply and divide by 10, 100, and 1000 using the patterns taught during this lesson. What is a pattern? Go ahead, take a guess. A pattern is a series or sequence that repeats. This sequence can be made up of objects, shapes, letters, or even numbers. In math, we can find patterns in lots of places, and many times we use them without knowing. Today, we will focus on patterns involving the numbers 10, 100, and 1000. Take a look. How many zeros do you see? That's right. There is 1 0 in the number 10. There are 2 zeros in 100. And you guessed it, there are 3 zeros in 1000. It's time to pause for a quick review. Do you remember what the parts of a multiplication problem are called? We have the multiplicand, the multiplier, and the product. So we know that the multiplicand and the multiplier are both factors. And when those factors are multiplied by each other, we get the product. How are patterns of 10, 100, and 1000 useful when multiplying? Let's investigate. When multiplying, your product will be increased by adding a zero to the end of the number. For example, 26 times 10 gives us 260. Add 1 zero to the end or the right of your number. When multiplying by 100, your product will be increased by adding 2 zeros to the end of the number. For example, 26 times 100 becomes 2,600. Add 2 zeros to the end or the right of your number. When multiplying by 1000, your product will be increased by adding 3 zeros to the end of your number. For example, 26 times 1000 equals 26,000. Add 3 zeros to the end or the right of your number. Let's take a second look. When multiplying by 10, 100, or 1000, we can see a special pattern. Pay attention to the number of zeros that you see. Each time, the number of zeros increase when the factors are multiplied by 10. Here's how it works. 10, which has 1 zero, becomes 100, which has 2 zeros, which then becomes 1000, which has 3 zeros. And this is because each time we multiply by 10. This means 10 times 10 gives us 100, and 100 times 10 gives us 1000. A simple way to think of it is you can think of it as adding a zero each time you multiply by 10 in this pattern. Are you ready to practice? Let's go. So here's how it works. 76 by 10, we know that the 76 should be increased by 1 zero. So the answer is 760. 15 is being multiplied by 100. Here, we have two zeros. So our 15, based on the pattern, will be increased by two zeros, giving us a product of 1,500. Then we have 88 times 1,000. Based on what we know from our pattern, 88 is being multiplied by 1,000, which has three zeros. Therefore, 88 times 1,000 will become 88,000. Can you try some on your own? Okay, here we go. 29 times 10. That's right, 290. 320 times 100. Awesome work! 32,000. 450 times 1,000. You are super smart. 450,000. Great job. And now it's time for a special bonus challenge. What do you see here? Yes, decimal points. When we have decimal points, it requires us to do something special. We have to actually move the decimal point when we multiply. For example, 0.5 times 10, instead of simply adding the 0, we will have to move our decimal point one time since we have 1 0. So when we move our decimal point, it will go behind the 5 and our answer will actually become 5. Next, we have 7.2 times 100. This time we have two zeros, so our decimal point should move two times. So that's once and that's twice. But you will notice now there's nothing behind the 2. Here is where we will add that 0, giving us an answer of 720. Finally, we have 0.25 times 1,000. We have three zeros, so we need to move our point three times. Here we go. 1, 2, and the third time, which is where our point should end up. So instead of having a decimal, we end up with yet another whole number, and this time the answer should be, drum roll please, 250. Great job. Inverse operations. Remember, multiplication and division are related. They are described as being inverse operations. This simply means that they are opposites. Inverse operations undo each other. Take a look at the chart on the left. Multiplication is the inverse of division, and that also means division is the inverse of multiplication. For example, 3 times 4 is equal to 12. But if we switched it around and we divided 12 by 3, what would we get? That's right, we would get 4. How are patterns of 10, 100, and 1,000 useful when dividing? Let's dive into division. First things first. Can you name the parts of a division problem? We have the dividend, which is the number that is being divided into, the divisor, the number that is being divided by, and of course the quotient, which is the answer of every division problem. And now we take another look at patterns, but this time when dividing. So when we are dividing by 10, your quotient will be decreased by moving one place to the left. This will many times involve moving an invisible decimal point. For example, let's look at this division problem. 26 divided by 10 is equal to 2.6. But how did that happen? The invisible decimal point is always located on the right of every whole number. So technically, 26 has an imaginary point at the end. Now, when we take that imaginary or that invisible decimal point and we move it one place to the left, because we are dividing by 10, which only has one zero, that is how we ended up with 2.6 as our quotient. So the whole number has now become a decimal. Very good. When dividing by 100, your quotient will be decreased by moving two places to the left. This may also involve moving the invisible decimal point. For example, 26 divided by 100 is equal to 0.26. Again, we have our invisible point, and we're moving it this time two places to the left because we have two zeros. So here we go, 1, 2. And this is where our point should now be placed. Placing a zero in front of your decimal point can make your decimal easier to read. When dividing by 1,000, your quotient will be decreased by moving three places to the left. This may also involve moving that invisible decimal point. For example, 26 divided by 100 becomes 0.026 because this time we need to move our invisible point three places to the left because we have three zeros in 1,000. So here we go. There goes 1, 2, and 3. But now we have an issue. There's an empty space. So in this empty space is where we would place a 0, which gave us the quotient 0.026. Be sure to add the correct amount of zeros before placing your decimal point. Are you ready to take a closer look? We can also see patterns when dividing by 10, 100, or 1,000. Pay attention to the amount of zeros that you see. Also, take special care to move the sometimes invisible decimal point when needed. When you divide by 10, 100, or 1,000, numbers decrease in intervals of 10. Here's how it works. We have 1,000, which has three zeros, would be decreased to 100, which has two zeros, which will then be decreased to 10, which only has, that's right, one zero. This is because every time we move, we are dividing by 10. So 1,000 divided by 10 gives us a quotient of 100. And 100 divided by 10 gives us the quotient 10. To make it simple, think of it as taking away a zero each time you divide by 10 in this pattern. Are you ready for another round of practice? Great! Let's go. 76 divided by 10 gives us the quotient 7.6 because our invisible point was moved one time to the left. Why? Because 10 only has one zero. Don't forget to look at the patterns. 15 divided by 100, our quotient will be 0.15 because our decimal point was moved two times. 88 divided by 1,000, the quotient will be 0.088 because the invisible point was moved 1, 2, and 3 times because there are three zeros in 1,000. Try these on your own. 29 divided by 10. Great! It is 2.9. 320 divided by 100. Fantastic. The quotient is 3.2. 450 divided by 1000 is equal to, you are right, 0.45. Oh, and here comes another bonus challenge. This time we already have decimal points. So instead of moving the invisible decimal point, we will move the visible decimal points that we can already see. So 0.5 divided by 10 gives us the quotient 0.05 because our point was moved one place to the left. In division, we always move to the left. 7.2 divided by 100 gives us the quotient 0.072 because we moved the point 2 times because of the pattern in the zeros. The 100 has 2 zeros. 0.25 divided by 1000. There are 3 zeros in this pattern, so our point should move 3 times. So here we go. 1, 2, 3. The quotient is 0.00025. Great job. We have covered patterns of multiplying and dividing by 10, 100, and 1000. Let's take a look at them side by side to see how they may be alike and how they are different. In multiplication, we can see a pattern of increasing by 0 each time we multiply by 10. However, in division, we can see a pattern of decreasing by 0 each time we divide by 10. In multiplication, additional zeros are placed at the end or to the right of the number. In division, the decimal point, whether visible or invisible, is moved to the left or towards the front of the number. In multiplication, movements happen in intervals of 10. In division, movements also happen in intervals of 10. In multiplication, you end up with a larger number than before, but in division, you end up with a smaller number than before. Now, boys and girls, you are ready to go forth and multiply or divide using patterns of 10, 100, and 1000 with confidence. Thank you for being a great listener. Great job to all of you. How about a round of applause? It has been awesome teaching you today about the patterns of multiplying and dividing by 10, 100, and 1000. My name is Miss Shavonna McMasters, and I will see you next time.